All right, this is a video of the review of Algebra 2, Unit 1, Topic 2. It's a Desmos activity. So the point of symmetry on this first one here is 1, 0. The domain is negative infinity, the font of infinity. So if you just type that on, you see a keyboard next to the problem, then it's a math slide. So you can just type infinity to negative infinity. Whenever you see this keyboard symbol, it's a math input thing. So the range, negative infinity to infinity, increasing, negative infinity to positive infinity. And this is NA or never. I'm just going to type never in there. Because if I type NA, then it comes out as a fraction because we're on the math input there. Slide 2, the endpoint is at 1, 2. The domain is square bracket 1 to infinity. The range is from this point here, 2 to infinity. So square bracket 2 comma infinity, increasing. So the answer keys on most of these put 2 comma infinity. If you put a square bracket, so mark that correct. Decreasing, this is never decreasing. All right, so match the original red graph with its inverse, the blue one. So let's move these around here a little bit. It's easier for me to use the slate for that. So let me see if I can get this here. We'll move these around. So if I look at this one here, the vertex, this red one is 1, 2, 3, -3, -6. So I want to go to -6, -3. That's this one here. So match those up. And then this vertex is at 1, 2, -1. So I want negative 1, 2, -1, 2. Let me pull this over here. So 1, 2, -1. 2, -1, I want -1, 2. Something's wrong here. Here I have -4, 0. So 0, -4. It goes with that one. And this one's at 0, 2. So 2, 0. Let's see if these two match up. 1, 2, 1, 2, 3, 4. So 4, 2. So which one was not? Oh, I was looking at the blue graph, I think. So those look right now. Okay. So I'd look at the vertex on each one of these and then swap the x and a y and then find the blue one with that swapped x and y vertex. All right, on this one, excuse me, if I type in here the restriction on the domain, so this is at -3, 0. So if I want this half the parabola here to be negative, x is greater than or equal to -3. So so I don't know how to prevent the shading from happening here with this math input, but you can just kind of ignore that. But you want to go from here over on the original. So then you want to write the inverse of this. So do y equal, and then the last thing we did was square, so the inverse would be square root of x. So if I just type SQRT in there, it comes up with the square root. I don't know what's going on here. Here's the keyboard. So I get this through square root on the keyboard also, which is underneath this here. It's right there. So then subtract 3. So the first thing that you do in the function is add 3. So in the inverse, you're going to do that last. So subtract 3. And then the inverse function looks like this here. That green shading is from this here. Maybe if I hold on to this. Yep. If you just click on that right there, I'll take the shading off if you don't want to see the shading. All right, this one here, the restriction on the domain, this is at 0, 2. Something's wrong with this. Oh, that's at 0, 1, or 1, 0. So this has, each of these are a half. Just wonder what was going on there. So the restriction on the domain is x is greater than or equal to. Oh, let me use the keyboard so you don't get confused here. So greater than or equal to is that one. And 1. If I want to take the shading off, I just click on that. And then the inverse function. So the last thing we did is square. So first thing we're going to do is square root x. Whoop. Let me get the square root first. Square root x. And then plus 1. Okay. All right. So that's what that looks like. And number 6, the vertex is at 2, 4. 2, 4. And so the restriction is going to be x is greater than or equal to 2. And once again, I just click on this and it takes the shading off. And then the inverse function. The last thing we did would be add 4. So first thing we're going to do is to x minus 4 but then I notice I need to take the square root of that, so I need to start over here and then get the x minus 4 under here. And then the last thing I'm going to do is inverse of subtract 2 is add 2. So that looks like that. And might want to, if you hold this down, then you can change the color of the graph. So there we go. Write the radical expression in exponential form. So this is the fourth root of the cube root of the square root. So this is x to the 1/2 times 1/3 times 1/4. So let me use the keyboard here. So starting from the inside, we have x and then the exponent for that is 1/2. And then the next exponent, let's see if I can just hit the cursor key here once. All right. And then a 1/3. That's not going to work. Let's try this again. So 1/2. Starting on the inside and working my way out. And then, oh, there we go. So I have to get the cursor over here. And then hit the fraction bar. So I don't know how to get dots in between there, but we want to multiply these three together. So 1 times 1 times 1 is 1. And then 2 times 3 times 4 is 24. So and then the exponent is 1 over 24. And then this one, I'd use the fraction bar, so I have a 1 in the denominator, x to the 2/6. Which equals 1 over x to the 1/3. Or you could write it x exponent negative 1/3. So either of these two answers I would accept. And then if you take the square root of this expression, square root of 4 is 2. And square root of x squared is x. And the square root of y to the 8th is y to the 4th. So 2x y to the fourth. And the last one here, 1 over x to the 1/7, which is the same as x exponent -1 over 7. So either of these answers here, I would accept there. And I had a hard time of making this in parentheses to the 8th power, so you want to multiply these two together. So m exponent 8/4, which is the same as 8 divided by 4 would be m squared. And this one is p exponent 10/3. Oh, we want to write it in radical form. Well, this one is, can't write it in radical form. So in radical form, so it's the cube root of p to the 10th. So to get the radical, you just do n root, nth root, type nth root, and then it gives you a radical symbol. So this is cube root, and then p to the 10th inside. And this one, if I do what's inside the parentheses here, so the top and the numerator, get x to the 8th. In the bottom, I get x to the 5th, sorry. X to the 5th. And close the parentheses there. And if I hit the caret key on the keyboard, so that's shift number 6, and then do the fraction bar, it's 1/2. So that equals x cubed. Let's see if this will work. So parentheses x cubed, and then shift 6 to the exponent, and then add 1 over 2, which is equal to x to the 3/2. So if I write that in radical form, it's the square root of x cubed. So this actually the square root is right there. So then x, and the exponent is 3. And then this last one, if I do what's inside the parentheses here, get x to the 4th in the numerator. Whoop. And x to the 12th, or x to the 20th in the denominator. And then let's see if like this will work. Yep. And that whole thing to the 1/2 power. So I do 4 minus 20 is 16. A negative 16. And then that to the 1/2 power. That equals x to the negative 1/8, or next to x to the negative 8. So there's a problem here. This can't be a radical, but you can write it 1 over x to the 8th. So 2 of those are really not in radical form when you simplify them. All right. And then the last slide here, it's, don't know if I square both sides here, x is 81. And then this one, let's see if I can write the steps out. So square root of x equals 7. And square both sides. So I'll just put a semicolon here for the steps, because I can't really type on the next line. So x is 49. When I square both sides, this one, subtract 2, and you have square root of x equal negative 7. X equal 49. If that doesn't check, I plug it back in, then 7 plus 2 doesn't equal negative 5, so this is extraneous. And here you have negative square root of 3x equals 7. So the next step would be divide by negative 1. So square root of 3x equal negative 7. And then square both sides. 3x equal 49. 49 thirds. So if I plug that back in, I have 1 minus 7 is equal to 8. So this is extraneous. And then this one, subtract 4 from both sides. And then square both sides. Should be 16. 5 by 2. So when I go to check it, 4 plus the square root of 16 is 4 is equal to 8. So that one works. Here, divide both sides by 3. So you can use this nth root symbol. So cube root of x equal 9. Then cube both sides. And then the cube root of 729 is 9 times 2 is 18. So x equals 729 is correct. This one, divide by -1. So you have the cube root of x equal -8. So 64 times 8 is 512, -512. And that would check if I plug that back in. And then the last one, whoops, I'm in the wrong box here. Let me delete that. All right. So cube root of x divide by -5 is equal to -2. And then cube both sides. -8. Plug it back in. Cube root of -8 is -2 times -5 is 10. So that one works also. So we actually got just 2, number 3, that had extraneous solutions. The rest work out when you check them.